Below is a very common set of numbers, 1, 2, 3, and so on. The 3 dots mean and so on. And I hope you can guess that the next number in the set is 4, followed by 5 and 6. This set has 2 names, counting numbers or natural numbers. The set goes on forever, so it is called an infinite set. Here's a related set, very similar to the first set. It's called whole numbers. This set starts with 0 and goes by ones, 0, 1, 2, 3, and so on. It also goes on forever, so it is also called an infinite set. And this infinite set is called integers. It's the positive numbers going by ones and also the negative numbers going by ones. Along with 0, it could also be called the whole numbers and their opposites. And if you're not sure what the word opposite means in this context, a pair of opposite numbers are 2 numbers that add up to 0, such as -2 and +2. The integers go on forever in both directions, so the integers is also an infinite set. Our 3 sets, counting numbers, whole numbers, and integers, can all be written as a list, known as the roster method. We often put these brackets around sets of numbers that can be written as lists. We can think of many more sets of infinite sets that can be written as lists, and here's 4 examples. Odd counting numbers, 1, 3, 5, and so on. Even counting numbers, 2, 4, 6, and so on. Even whole numbers, 0, 2, 4, and so on. And the odd integers, 1, 3, 5, and so on, along with -1, -3, -5, and so on. This is a number line. This is also a number line. It's vertical. The first one was horizontal. With vertical number lines, we usually put the positive numbers on the top and the negative numbers on the bottom. And with horizontal number lines, we usually put the positive numbers on the right and the negative numbers on the left. The green dot on this horizontal number line might represent the number 4.5. And the blue dot might represent the number -2 1/3. Any number that can be represented by a fraction with an integer numerator and an integer denominator is called a rational number. Our first example, 4.5, can be written as 4½ which can then be written as 9/2. 9 is an integer, 2 is an integer, 9/2 is a fraction, so 4.5, since it can be written as a fraction with an integer numerator and denominator, 4.5 is a rational number. So is -2 1/3, because it can be written as -7/3, which are both integers. And by the way, when you're talking about negative fractions, you can put the negative side on the numerator as shown, or on the denominator as shown in the middle example, or right in the middle between the numerator and the denominator. All 3 of those representations on the bottom are all acceptable ways to write the improper fraction -7/3. Any number that can be represented on a number line is a member of another set of numbers, real numbers. And there's one more set of numbers that are part of real numbers that we haven't discussed yet, and they're called irrational numbers. Irrational numbers are infinite, non-repeating decimals. Perhaps you already know of some. Here are some examples. Pi, the square root of 2, -pi, and -√3. And we can represent all 4 of those irrational numbers on the number line. Take a look at the top. They're all represented by blue dots. Real numbers cannot be written using the roster method, so we often graph sets of real numbers. Here's one such set. It's not all of the real numbers, but it's a set made up of real numbers called positive numbers, all the numbers greater than 0. We can't write them using the roster method, so graphing is a good way to do it. We make the thick red line with the arrow to show that positive numbers start just to the right of 0. In fact, any number to the right of 0 is positive, and they go on forever, infinitely, and that's why we put the arrow on the right end of our red line. If you only have one color, just make the set that you're graphing thicker than the original number line. Here's another important set, negative numbers. All the numbers to the left of 0 on the number line. The arrow starts at 0, but it goes on forever to the left instead of to the right. And we mark 0 because 0 is an important marker when determining positive and negative numbers, but the circle around the 0 is empty because 0 is neither positive nor negative. But any number to the left of 0 is negative, and any number to the right of 0 is positive. In this lesson, we looked at counting numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers, positive numbers, and negative numbers.